Scott talked about alluvial fans. He also talked about flooding, landslides, and debris torrents. These are matters all of us are going to have to take greater interest in the future. By midnight, Pomeroy observed that the water was already backed up into the streets and homes and noted that what he was seeing was way too close to what he'd predicted in an article in which he'd been quoted in the Calgary Herald the month before. The May 26th article by Matt McClure ran under a headline which read, "Alberta urged to prepare for increased severe weather as insurance losses mount." In the article, McClure cited a new report prepared by the Insurance Bureau of Canada for the Institute for Catastrophic Loss Reduction that demonstrated that the losses in Alberta have mounted to an average of $670 million a year over the past 4 years, compared to an average of only $100 million a year for each of the previous 15 years. John Pomeroy responded to this observation in the article by pointing directly to the flood threat in Canmore, where, quote, "there are areas like Cougar Creek subdivision in alluvial fans that are particularly vulnerable." Less than a half an hour after John reported the rising waters to his colleagues, Cougar Creek breached the Trans-Canada Highway in Canmore. Within a few minutes of closing the Trans-Canada in both directions, the RCMP began knocking on doors in the Cougar Creek subdivision to warn residents to be prepared to evacuate. The rain and flooding continued throughout the night. At 5:15 a.m. on Thursday the 20th, the Alberta Environment issued another flood watch update but did not issue a flood warning for Canmore. At 6:45 a.m., 23 truckers and an RCMP officer were trapped by floodwaters on the Trans-Canada Highway and had to be rescued by helicopter. At 8:45 a.m., after almost 6 hours after a local state of emergency had been declared, Alberta Environment issued an official flood warning. During the night, a spectacularly swollen pulse of floodwater flowed downstream from the mountains into the unprepared city of Calgary. 20 neighborhoods had to be evacuated and more than 100,000 people forced from their homes. But Calgary wasn't the only municipality in trouble. 12 southern Alberta communities had declared states of emergency. 8 communities besides Calgary were under evacuation orders. And the flooding, as some of you may know, was particularly serious in small towns immediately south of Calgary. The floodwaters had risen so quickly in High River that residents were trapped in their cars and in their homes and had to be rescued from their roofs. The town of High River was almost completely inundated. 2/3 of the community flooded, and 5,000 residents were forced from their homes, including my sister and her husband, who lost everything. In Europe, storms of this magnitude are now being called decision-making rains. And they're called that for obvious reasons. Policies after these events need to be examined and possibly changed. At 9:36 a.m., the Premier's office in Edmonton announced that Alison Redford would personally tour Lethbridge, Canmore, and High River later in the day. At 10:40 a.m., Prime Minister Stephen Harper left Ottawa to survey the damage. Aerial images of Calgary that morning show extensive flooding in many neighborhoods near the banks of the Bow, but also hitherto unimaginable flooding in the concentrated downtown area. The following day, some 1,300 Canadian soldiers were sent into the flood zones. A clearly shaken Premier Redford announced $1 billion in emergency disaster relief. That, however, would be far from enough. So, what did we learn in Alberta that might be helpful to you? We learned that while the province responded relatively effectively in recovery efforts immediately after the flood, it was clear that the right systems were not in place to predict and manage events of this magnitude. Flood warnings were not issued in many places until evacuation orders had already been issued. And while the government says, well, there wasn't a problem, the concern is still being expressed that not enough attention is being focused on the inadequacy and failure of Alberta's flood forecasting systems, which I should point out to you as an outside observer, should not be attributed to a lack of skill or knowledge of individual forecasters, but to systemic problems relating to budget cuts, staff reductions, reliance on outdated forecasting tools, and inadequate field monitoring. New forecasting technologies are available and need to be adopted, and it's time, I think, to move toward coupled hydrological and meteorological modeling in near real time. Enhanced modeling should ideally be linked, and this is what we missed in Canmore, to a denser network of mountain meteorological stations and stream gauge stations, especially in small tributary creeks prone to flash flooding. But what we really need larger than that is a national flood prediction program linking enhanced meteorology to Canadian Water Survey programs in the provinces. The second lesson that we learned was that our provincial flood maps have allowed to become inaccurate and largely irrelevant. And the systemic failure to adequately forecast flooding over the long term is evidenced by the fact that the government is left with no choice but to utilize 20-year-old floodplain maps as a foundation for deciding on present and future eligibility for flood damage compensation. Now, this is a really serious difficulty in my mind and in the minds of other colleagues in our group. This is a poor option to have to rely on. It's rather like having a life crisis at 50 and going back to the time when you were 30 and basing future choices on what you knew and what was happening in the world then. 1994 flood maps do not account for many of the things that Scott talked about this morning, for landform changes, for erosion, for groundwater dynamics. They assume the stationarity of flows, and we know that that stationarity doesn't exist anymore. Another thing that was very important that might be useful to you is that such maps also fail to properly account for the fact that the value of vulnerable properties in floodplains has increased exponentially since these maps were drawn. So our maps should not tell us what the world was like 20 years ago. They should help us understand what to expect 20, 30, or 40 years in the future. And though we cling in Alberta to current 1 in 100-year flood event standards, they don't tell us much. Those maps tell us what we might have expected in 1950. We need to know what to expect in 2050. There's another thing that I wish you to consider on this. Alberta's flood maps are based on average flows. Now, all of you are air travelers. Would you design a passenger airplane based on average conditions in which it would be flowing? No, you would design the plane to withstand known extremes, and then you'd add a margin of safety on top of that. That's what flood maps need to do. And we now have thousands of new data points that can tell us where the real floodplains in southern Alberta are located. But hydrologists need to do intermodal comparisons in the same manner in which climate scientists compare a broad range of model outcomes to establish future scenarios. And we also, and this was a deeply painful lesson, learned that, as so many others have, that the loss of hydrologic stability has the potential to cause a great deal of human misery and suffering, even in a very prosperous province. Disaster relief is not the same as insurance, and I think you know that here. It's winter now. Those on or driven to the margins will suffer the most, and if they are forgotten, their problems, as we've already seen in Manitoba, will have legal and political consequences for government at all levels for decades to come. There's always a temptation and often a great deal of political pressure applied after a disaster to try to remake the world as it was. But that's not going to be possible. Everyone has to be involved in dealing with the increased threat of such events. And the U.S. has made disaster resilience a national imperative. We ought to give that consideration here too. Final lesson is that what we've seen is likely going to be what we're going to get. When supposed experts tell you that we don't have to worry because the Earth has experienced higher carbon dioxide concentrations and warmer temperatures in the past, what they don't usually tell you is that during these epochs, extreme weather events lasted for days and sometimes weeks. There's already been a 4% increase in relative humidity globally over the last century. Predicted rises in temperatures of between 2 degrees Celsius and 6 degrees Celsius would result in further amplification of the hydrological cycle by 15 to 40% or more. So the problem's not going to go away. And it certainly didn't go away after the floodwaters receded in Alberta. This is what downtown Toronto looked like on July 8th of this year. The uncertainty of a changing climate clearly demands a faster response. But what we have seen in the news lately aside, making decisions and funding action in a municipality like Toronto is akin to moving mountains. An unfit stormwater system, the crippling cost of replacing it, and a host of competing political interests prevent Toronto from becoming a resilient city. And unfortunately, the flooding in Alberta and Ontario in June and July is nothing compared to what the atmosphere has demonstrated it's capable of delivering in the future. And this was made more evident by a series of extreme events that happened in Russia shortly after the flooding in Canada. And we didn't hear about this because we were obsessed in the news with our own problems, but what happened in Russia is almost beyond imagination. It's the stuff, really, of science fiction. The weakening of the European jet stream caused by reduced snow and ice cover led to the creation of a heat dome over northern Siberia. In July, hundreds of wildfires broke out that were so hot they melted the permafrost beneath the burning forests, creating methane releases from the thawing tundra that added fuel to the fires. Then, in early August, in the midst of what was coming to resemble a virtual firestorm, 3 atmospheric rivers collided over the region and within 4 days created a flood that covered 1 million square kilometers. Again, we see floods and fires of a magnitude seldom experienced before in the same basin in the same year. And we saw the same theme repeated right before our eyes in Colorado, fires and massive floods in the same basin in the same year. Now, I was just recently in Colorado where experts told me that when the storm started, what it started was a strong plume of tropical moisture that moved up from Mexico. And at first the rain was welcomed. It ended the drought and put out the forest fires. The storm, however, dropped 19.8 inches of rain in the Boulder area, which is unprecedented for any storm in the month of September. So we're seeing these storms occurring at different times of the year. Now, this is interesting. We wait till you hear this. Colorado state climatologist Nolan Deskin noted that the remarkable feature of the storm was not the cloudburst per se, but the atmospheric water levels. The storm, he said, shattered all records for the most water vapor in the atmosphere. So the world is clearly shrinking. Maybe we should talk. So what are the larger lessons that we can learn from this? The overarching lesson we can learn from this is that the loss of hydrologic stability could be a much bigger problem than we initially thought. The systemic threats we face are part of a single connected hydrologic whole. Every part of the water cycle flows through and affects and is affected by every other part. Changes in the extent and duration of Arctic sea ice and northern snowpack and snow cover have begun to have a cascading effect on weather and climate right down to the mid-latitudes. So in a sense, you could see the loss of hydrologic stationarity as something of a societal game changer. It means that simply managing water in ways that are useful to us will no longer be enough. We have to be alert to changes in the larger global hydrologic cycle and where possible try to manage and adapt to them. And this is a big concept because it goes far beyond what any of us as water managers have been thinking about and doing. And it's going to take time to get our heads around it. And in this context, we learned in Alberta certainly that the watershed basin is the minimum unit at which water must be managed. And lesson 3 is that we need nature's help. While breakthroughs will be helpful, we can't rely on engineering alone. In order to gain even partial control over the hydrologic cycle, we have to enlist all the help that nature can provide us. And we can gain that help by protecting and restoring critical aquatic ecosystem function and reversing land and soil degradation wherever we can. Finally, we have created a number of vicious circles we need to break. One of them is your outside water use in this basin, I wanted to point out. But it's widespread. What we see here in Canada is that we're the most profligate water wasters in the world. We waste water, and now we find that the energy we use to move water to where it's wasted is in part generating extreme weather events that are pounding the hell out of the infrastructure we can't afford to build, maintain, and replace. So clearly, that's an easy one. We've also created similar vicious circles in agriculture where we waste energy over applying nutrients and other substances that contaminate our rivers and lakes in ways that we can't afford to treat. We can break these cycles easily and save money and directly improve our adaptive capacity on the way. But water, energy, and conservation are the beginning, not the end. The new normal, I regret, is that there probably isn't going to be a new normal and won't be until we stabilize atmospheric temperatures. So unless we want our future to continue being a moving target, sooner or later, we're going to have to confront the root cause, a subject I can tell you no one wants to talk about, at least where I live in Alberta. So what do we do now? Firstly, it's important to recognize that this is not the time to throw up our hands in helpless despair. Such behavior is unacceptable. The sky is not falling, the world's not coming to an end. But this is an important time, and this is an important time for thoughtful and persistent leadership of the kind that I know is in this room. It's not going to be easy. We face issues that could be divisive enough to tear our society apart. But I would submit to you that it's the moral duty of everyone in this room to make sure that that doesn't happen. We have to work as hard on determining the principles of hope by which we are individually motivated as we do on adaptation strategies for our communities. Strong and hopeful leadership will define effective future adaptive capacity. Can we manage the hydrologic cycle and what it does to preserve our quality of life and the resilience of the systems, natural and otherwise, that are the foundation of our prosperity? Well, my answer to that question is yes. Of course we can. We know what to do. In this room, there are skills and knowledge that can help you do exactly that for your basin. There's still room to move if we wish to preserve what we have, but we would be wise to get moving, all of us, as fast as we can while that room still exists. Thank you.